Hello, so in today's video, we're going to look at the meaning of a geometric sequence. So what is a geometric sequence? So I've listed some examples here of geometric sequences. So for example, 2, 4, 8, 16, 32. So we can see the pattern with this sequence is that we're multiplying by 2 each time to get the next number. That's the pattern with that sequence. The next one is also called a geometric sequence as well. So what's the pattern with this sequence? So each time we're actually dividing by 3 or multiplying by 1/3. We can think about it like that. So multiply by 1/3 each time. And likewise with this one at the bottom here. So what's the pattern with this sequence? So this sequence, we're multiplying by -1 each time. So every time to get the next number in the sequence, we multiply the previous one by -1. So what is a geometric sequence then? So a geometric sequence is a sequence whereby the next term in the sequence is generated by multiplying the previous term by a constant common number. So basically, if we go back to these sequences here, we're multiplying the previous term by the same number each time in order to generate the next term in the sequence. So this one, we've got a number 2 that we're multiplying by each time, a third in the second one we're multiplying by each time, and in the last one we're multiplying each time by -1. So that's what a geometric sequence is, and the number that you multiply by each time is called the common ratio. So we call it the common ratio, and usually we use the letter R for it. So R means common ratio. So yeah, we'll be using the letter R in the future. So the letter R is what we call the common ratio. So in this case up here, the R value would be 2. With this sequence here, the R value would be a third, and with this one here, the R value would be -1. Okay, so here's another example. So we got 721, 63, 189. So each time we're multiplying by 3 with this sequence here. So the common ratio R, this common ratio value, is going to be 3. And the A value, again, like with the arithmetic sequences that we looked at before, the A is always the first term. So again, it's convention to use A as your first term. So in this case, A is going to be 7 in this question here. So A is called your first term of the sequence, and R is called your common ratio. Okay, so let's go to the next slide. So can we generate an iterative formula for a geometric sequence? So if we call A the first term of the sequence, R the common ratio, then we know the geometric sequence with the first term of A and a common ratio of R is going to look like this. So A times by R gives you the next term, then times this AR by R again, that's going to get you the next term of the sequence, and then that's going to get you the next term of the sequence there, AR cubed, and then times that by R, you're going to get the next term, AR to the power 4. So this is our first term, that's our second term, this is our third term, this is our fourth term, and this is our fifth term, and so on and so on. So the iterative formula for this sequence, so the next term in the sequence, an plus 1, is going to be the previous term, an plus what? Sorry, just an, multiplied by R, the common ratio. So an plus 1 equals the common ratio times by the previous number of the sequence, where the first number of the sequence, A0, we will call that to be A. So A is our first number in the sequence, and then the next numbers that we generate in the sequence, you just times by R to get your next number. So that's our iterative formula for a geometric sequence. Now, how about the nth term of the geometric sequence? So again, if we just write out our geometric sequence, so first term A, next term AR squared, times by R each time. So what about our nth terms? I mean, this is our first term, that's our second term here, AR. Our third term is going to be AR squared. Our fourth term is going to be AR cubed. Our fifth term would be AR to the power 4. So that's going to be our fifth term. So what would our nth term be? Well, our nth term, well, let's do our n minus 1th term. So a times r to the power of n minus 2, that's going to be our n minus 1th term. And why is that? Because again, if we look at these numbers down here, for example, AR squared, that's our third term. So the power is 1 less than the number, the term number, basically. And here again, the same thing, AR to the power 3, that power is 1 less than the term number 4. So basically, n minus 2 is 1 less than n minus 1. So a times r to the a times r to the power of n minus 2 is the n minus 1 term. So a times r to the power of n minus 1 is going to be our nth term. So this is our nth term there. So our nth term formula is going to be a times r to the power of n minus 1. That's our nth term formula. Okay, so then, yeah, that's the end of today's video then. So this is just a summary of how you can find iterative formulas for geometric sequences, and how you can actually calculate the nth term of a geometric sequence. So the nth term of a geometric sequence is the first number times by the common ratio to the power of n minus 1. So yeah, that's just what I wanted to go through today in this video.